Chapter 9, sections 3, 4, and 5. What questions do you have for me? Nine point four. Okay. So we know this is a logistic differential equation, right? Because we see that format. Now they actually give me both of these numbers. And they give me an initial condition. So far, so good? Well, I have a distinct advantage. If I know this is the setup for the equation, I know what the answer is supposed to look like. What's the solution that we went through on Monday when I do a logistic differential equation? Say it again. Now I used capital K. Down here, they're using an M, so I've just swapped out the letter. Wait a minute. I know this number. I know this number. The only thing I have to solve for is that one. And I can use that to do it. If you want to, you can go back through the whole derivation, but you're basically redoing the entire partial fractions and calculation we did on Monday. There's no reason to do it again. You want to know what the population is 1 year later? T is measured in years, so after you solve for that, part A says find y of 1. And part B says how long will it take to reach 4 times 10 to the 7th? How long will it take the population double? Okay, then I know. I have to solve for the T in that case. You can do that either manually or you can graph both equations. It also helps if you know what this number is. I don't know what it is off the top of my head, but if that's bigger than 4, I know it's going to take less than a year. If that's like 2.7 or something, it's probably going to take a couple of years. That gives me a rough scale. So I don't have to go down like T 100 or something. Better? Wonderful. There is in the textbook a formula written for A in terms of our carrying capacity M and our starting population, our initial condition. Yeah, here it is. When we did all of the actual algebra, I just said you could solve for A. I actually give a formula for it right there. But I honestly can tell you I've never memorized that formula. I've never used it. I always just plug in the 2 numbers and go from there. More questions? 42. Is this the sphere question?
Yeah.
Okay. So this trick, this technique is actually common. We're given a second order differential equation. Right? And they say, I'm going to make a change of variable. I'm going to let S be this derivative. Then what goes here? Almost. This is a second derivative, right? Well, if this is my first derivative, then this is the derivative of S with respect to R. So what I've just done is I've taken a second order differential equation and I've made it into a first order differential equation. This trick, I hope is not a surprising name, is called reduction of order. But that equation, that's separable. I'll solve it, right? So I do some work and I get S equals. And this is going to be some function of R. I don't know what it is. But we want T, not S. But this is the same as saying T prime equals. Okay, wait a second. Now I'll do another integral. Right? Now, please note that when I went from here to here, I did an integral. So there'll be a plus C somewhere in this line. When I integrate again, there'll be another constant. Because when I integrate plus C, I'll get C times R. So this has two constants in it. Now, if I have two constants, I'm going to need to be able to solve for both of them. In the problem, what do they tell me about T?
That distance R from the common center of the sphere.
Because I have two spheres, right? With two different diameters, two different radii. The first sphere has a radius of, and the second. But wait, there's more. The sphere of radius 1 has a temperature. Yes? Well, that means that T of 1 is 15. What about the second sphere? I have two conditions. I can solve for two different constants. Now, this is going to require some simultaneous equation work, maybe, because neither of these are 0. And it makes sense that neither of them should be 0 because I had 2 over R in this problem. I can't divide by 0. I know they did it in terms of temperature, but I can change this problem about this much and make it relevant to electrical engineering. Make these two spheres out of metal, and instead of measuring the temperature, let's measure the electric field between the two of them. One of them being a positive charge, the other one being a negative charge. How's the electricity That's a capacitor. I have those in my pocket on my phone. And when we adjust the distance in the capacitor, we can get electricity to move between them. People, that's how a touch screen works. This electricity that's in my finger moves through the capacitive screen. I can take that and make it biology. Instead of metal spheres, let's look at semi-permeable membranes that are both spherical. And then we can have some chemical inside. We can look at the diffusion of that chemical. Well, that should be smaller the bigger the radius, right? More volume means less chemical concentration. It should be inversely proportional to the radius. The further away you are, the less chemical you have. I can play with this all day long. I'll make it fit anything. And that's the best part about these particular problems, is that I've set up particular framing for them, but they're applicable so many other places. Better, Don?
Yeah.
Wonderful. More questions? Yes, Norm? What's on the other side? Yes, I would need to get the E for all of that, right? So when I exponentiate on this side, I'll get S. And over here, I'll have e to the negative 2 ln r plus c. But e to the c is a constant. And then e to the minus 2 ln r. Yes? What do I do with a number in front of a logarithm? Ready? E and ln cancel. You're welcome. And why did I get rid of the absolute value? Because I'm squaring, aren't I? So whether it was positive or negative, it's not going to be positive. It's almost never the calculus part that's a pain in the ass. The algebra, on the other hand, sucks. And then that'll be one of the constants I solve for. I'll integrate again to get t. I'll use my two conditions, and I'll have two constants to solve. Ask me more things. Nine point five 16. So t cubed dy dt, that one? Okay. Okay. Now, my problem is that this is not set up to be linear yet. What do I need to do?
Like T on one side of it.
It should always be with the y part, not with the y prime. So this is the problem right here. This t cubed needs to go. So I'll divide it out. Now, I apologize in advance because this is linear, y prime, p of t times y equals q of t. So I need an integrating factor. What's my integrating factor?
This is the U of X.
We integrate. And so really I shouldn't be using x, it should be t. But that's okay, my apologies. What's the integral of 3 over t? This one type. Nor I'm in the same spot. What do? I put it on the inside. That means this is now e to the ln t cubed. Wait a minute. What happens? Because the e and the ln cancel each other out. That means I got to multiply everything by t cubed. Didn't I just divide by t cubed? This literally puts me right back where I started. This is why I was apologizing. Because I didn't recognize that this was already in the product rule form that I needed. The t cubed times the derivative of y, and then plus, hey, 3t squared is the derivative of the t cubed. Son of a, that's first derivative, second derivative, that's already product rule. I just didn't notice. Yeah. Which means that this left-hand side is t cubed y prime. Integrate. You get rid of the prime. Divide by the t cubed, and you can solve for the plus c. Have to remember to do that integrating factor. Probably should have checked first, but sometimes it's not worth it. You just do the process. I know it's going to work. Better? Wonderful. If I had looked at the beginning and gone, oh yeah, that's product rule, I could have just gone right from here to here, but I didn't notice. Make it linear, do the integrating factor. Crap, I'm back where I started. Oh, but then I know what the next line is. It's I times y prime. Oh, and I would like to point out to you all some of the more interesting things. We're doing U substitutions almost unconsciously now. We're doing them all the time. We're doing integration by parts regularly. It's Yeah, that's familiar. In August, you wanted to hit me with a stick. Now we're good at it. Yes, I know some of you definitely still want to hit me with a stick, but that's a separate issue. Sadists, all of you. No, that's me. Tell you the bad joke that goes with that? Well, of course you all are here for the pain, right? We're all a bunch of masochists. Come on. More questions, please, before I continue to be silly.
Is the final exam like, is it as long as our previous test or is it longer?
It's longer because you get 2 hours for it.
Yeah.
It's not necessarily twice as long, but it is comprehensive. And well, yeah, we'll go through the whole thing Monday, whatever you want to know. I believe so. I'd have to go back through and count points, but I think it's pretty evenly divided. It would be very rude of me to suddenly pull out something that I didn't think was important enough for you to already have been tested on. But all of chapter 9 is new stuff. And I don't think things that will show up should surprise anybody. On the other hand, I've had people walk into my exams with, I've never seen this before. You were here yesterday. Where were you? Plus, we have that wonderful problem that our exam is at 8 in the morning. See, but your exam is at 8 in the morning on Wednesday. I have another group that's got their morning 8 a.m. exam on Tuesday. Half of that Tuesday 8 a.m. class is in my 1 o'clock exam on Tuesday. So they have me for 2 exams in the same day. It's almost as bad as when Calc 1 and Discrete were on the same day. Yeah, no, not a good thing. More questions?
What are we gonna do tomorrow?
I have another piece of differential equations that I want to look at. And it's really, could I do this second order differential equation in a different fashion? And it turns out that a lot of second order differential equations can be solved strictly algebraically without really doing any calculus. I just want to show you why. And then that's really, I'll talk about that until you take the DiffEQ course. Yep. There are 2 things I want to accomplish Monday. I want to make sure everybody has done their student evaluation for the course so that I get your feedback. So if you haven't done it by then, I'm going to give some time in class to do it by then. And if everybody's done it, we'll just launch into the review. And I'll answer any question you want to know about the final. Yes, I will answer any question you want to know about the final. I will answer the question. Please notice the way I phrased that. Can you give me the answer to the third problem on the exam? No is a complete answer. I've been at this game for 30 years. I learned some of those tricks. My favorite one was the person who said, "Can I see the exam?" And I went, "Yes, ready?" I had an instructor who would, during the exam, you could come up and ask for help. And he would write down the next step of the problem for you. But it was 2 points out of 10. So if it's a 10-point problem, you now get a maximum of 8, but here's the next step. And I think he said you can only do it twice per exam. I didn't like that.
Is it just the same reference sheet that they give?
Yes, the one that's attached to the review sheet with the same 1.5 pages worth of stuff. No, that's right, because it was the same one that was attached to exam review 3 and exam review 2. You'll get the same stuff. I don't have a reason to keep you all nailed to these chairs, people. Ask me questions or I'll let you go. Take your pick. If you need to leave, that is perfectly acceptable at this point. I will be here for another 20 minutes. Otherwise, I will see you all tomorrow. Or Monday, as the case may be. And you get to go have coffee. Please make sure that is
Actually, you set up one of California's problems.
maybe.
Let's try and help them with their homework. Even Amy and I were trying to bring together. They're not allowed to.
Come around over here.
They're not allowed to use physical books. Other than like ethical. Right. I need to get an A on my food and final and then do pass this one. That's how it is.
What are the chances of that?
An A on the okay. Well, hello, Birdie told me to get another card where we can write every single reaction, so I'm very happy with that.